Hi guys, welcome back to my YouTube channel. I don't know what to say. Mwalimu RGG, please subscribe to my YouTube channel. Alafu mambo itakuwa bulai. Anyway, today we want to do matrices. So matrices is plural of the word a matrix. So what is a matrix? A matrix is, okay, let's define what a matrix is. A matrix is a set of numbers arranged in rows and column to form a rectangular array. So it's a set of number arranged in rows and columns to form a rectangular array. So for example, something like 2, 1, 2, 4, 6. So this is an example of a matrix. So array can be a rectangle or a square, like 2, 1, 4, 1. Or also you can have something like 4, 4, 1, 2, 6, 1, 5, 0, 5, 6. So this is just examples of a matrix. You can find example of a matrix. So these numbers inside a matrix are called elements. So this one is an element in this matrix, an element. So these are elements. Elements, they are the numbers inside a matrix is called an element. So we want to give these matrices names. So order of matrix, order of matrix. So we can say order of matrix. This is matrices. Let's say order of matrices. This is just like giving matrix names, okay? So we give matrix name using their number of rows and the number of columns that it has, okay? So we're giving matrices names according to the number of rows and the number of columns that it has. So for example, we have a matrix with n rows and m columns is of order m. So you start with the number of rows and the number of by the number of columns. So it is a n m matrix, n by m matrix. So for example, let's do a real example here. A matrix like this one. Let's do this 2, 1, 2, 2, 1, 2, 4, 6, 1, 11. 2, 1, 2, 4, 6, 1. So we count the number of rows that it has. So it has 1, 2. Rows nizo zimeenda hivyo. So it has 1, 2. So it has 2 rows and how many columns? 1, 2, 3. Columns ni hizi and rows ni hizo. So it has 1, 2, 3 columns. So it is called a 2 by 3. It is called a 2 by, it is of order 2 by 3 matrix. So this is just like giving a matrix its name, and we name it according to the number of rows that it has and the number of columns that it has. So for example, that one is a 2 by 3 matrix. It's of order 2 by 3. Okay? So, for example, we can do this. If this matrix is so it has how many rows? Rows ni hiyo moja, 1, 2. And columns, so it has 2 rows and 1, 2, 3, 4. 4 columns. So we can call this matrix a 2 by 4 matrix. Or we can say that it is of order 2 by 4. Awi, mpaka hapo tuko sawa? Okay. So after we have known how to name our matrix or how to give the order of a matrix, we can now do what? We can now do something called, we can find out about equal matrices. Equal matrix. When do we say that this matrix is equal to this matrix? So we say that if the elements of the first matrix is equal to the elements of the second matrix. So for example, equal matrix. So we can say that matrix are equal. We can say matrix or matrices are equal if corresponding elements are equal throughout. So if corresponding elements are equal throughout, that is when we state that matrix, the matrix is, they are equal. So for example, if matrix A is 2, 4, 3, 4, 1, 0. No. If that is matrix A and matrix B is A, B, C, A, B, C, 2. So if we say that matrix A and B are equal, in this case, the corresponding elements should be equal. So in this instance, if A equal to hapa, the first row, first column has to be equal. So here we'll say that A is equals to 2. Okay? A is equals to 2 or 2 is equals to A. 2 is equals to A. If this matrix A and matrix B are equal, corresponding elements should be equal. So for the first row, second column, we'll say that 4 is equals to B. 3 is equals to C. And this 4, second row, first column is equals to A1, and 1 is equals to B2, and 0 is equals to C3. This is, when we say an equal matrix, is when corresponding elements are equal throughout. But if here could be let's say here, let's say 0, but here we find that it's 3. That this matrix, they are not equal. The element that should be here should be also here. It's the same as the one that should be here. That is why we say this matrix are equal. Are we together? So if you know equal matrix, so we should back up. I hope tuko sawa. So equal matrix, corresponding elements are equal throughout. Then after we've known about what a matrix is, what an element is, let us now do addition and subtraction of matrix. But in this lesson or this lecture, we will do a 2 by 2 matrix throughout. And then with another lecture, nitafanya a 3 by 3 matrix. So, addition and subtraction of a 2 by 2 matrix, and also multiplication. So, let's do this. Addition So let us do addition and subtraction of matrices. So we have some rules that will govern that. So the first rule is that when adding or subtracting matrices, it must be of the same order. We know what order is. So the first rule, rules, number 1, they must be of the same order. Like for example, a 2 by 2 matrix can only be added or subtracted by a 2 by 2 matrix. A 3 by 2 matrix can only be added and subtracted by a 3 by 2 matrix. That is what we say of the same order. Then rule number 2, we add and subtract corresponding elements. We add and subtract corresponding elements. Adding and subtracting of matrices. In this case, we say a 2 by 2 matrix, or a matrix of order, or matrices of order 2 by 2. So we add and subtract corresponding elements. So we know what elements are. So let us say, for example, 4, 2, 3, 5, 7, 6 plus 4, 2, 3, 5, 7, 6 plus 1, 8, 9, 3, 5, 4. So when you say we are adding this, so it's equals to, we are adding corresponding elements. 4 plus 1. So elements, the first row, first column, first row, first column. That is what we mean by corresponding elements. First row, first column, first row, first column. So we will add 4 plus 1. Then we come to second row. First row, second column is 2, and this one is 9. So 2 plus 9. Then we come to the first row, third column. It's 3, and this other side is 9. 3 plus 9. So 3 plus 9. We come down. The second row, first column, 5 plus 3. So we come 5 plus... I'm doing a 3 by 3 matrix, but it's Then 7 plus 5. 7 plus 5. And then we come the second row, third column, plus 6. 6 plus 4. So it's 6 plus 4. So your answer will be 4 plus 1 is 5. 5. 9, 10, 11. 9, 10, 11, 12. 12. 5, 6, 7, 8. 8, 7, 8, 9, 10, 11, 12. 12, 6 upon 10. So when we add this matrix plus this matrix, we find our answer as that. But in this case, we were saying we wanted to do a 2 by 2 matrix. So let us now try a real example of a 2 by 2. Actually, it's going to put So for instance, matrix A. For instance, matrix A with we improvise, like, okay. Improvise, like, if matrix A is 3 and 23, 2, 1, 4, 2. Matrix B is 6, 8, 4, 2. So matrix A is that, matrix B is that. So A plus B, A plus B will give you, so you quote that 2, 1, 4, 2 plus B is 6, 8, 6, 8, 4, 2. So we add corresponding elements. So it is 2 plus 6. So the answer will be 2 plus 6. Then 8, 1 plus 8. Then 4 plus 4. And then we get 2 plus 2. So our answer will be 2 plus 6 is 6, 7, 8. 8, 9. 4 plus 4. 8, 2 plus 2, 4. So your answer will be that. So A plus B is equals to that. Very, very simple. So we want to see if, for example, we say A, we just use this. So we can say B minus A. We want to see how we subtract matrices. So this is addition. We add corresponding elements. 2 plus 6, 2 plus 6. Then we add 1 plus 8. Then we add 4 plus 4. Then we add 2 plus 2. Those are corresponding elements. Back up, I hope to naendelea salama. So we can continue. We want to do now subtraction. That was addition. So let us see subtraction using these matrices. This is A2. A is this, B is this. So we can say B minus A. So B minus A, you come and quote. What is B? B is 6, 8, 4, 2. 6, 8, 4, 2 minus 2, 1, 4, 4, 2. So when we want to subtract that, how do we do? We subtract corresponding elements. So for example, our answer will be, so B minus A is 6 minus 2 minus 2, 8 minus 1, 8 minus 1, 4 minus 4, 4 minus 4, then 2 minus 2 minus 2. So that is how we do it. So your answer will be, so B minus A, itakuwa 6 minus 2 ni 4, si ndio? 8 minus 1, 7. 4 minus 4, 0. 2 minus 2, 0. So that is B minus A. Very simple. We subtract corresponding elements the way we have added corresponding element. This is corresponding with that. That is corresponding with that. This with this. So we can only add or subtract elements with the same order. Back up on the same. Sawa, sisi tunaendelea. Okay. So let us do multiplication. Let us do multiplication. Just retain our matrices here. So multiplication. Multiplication of matrices. So first of all, we start by, let me just grab this one also. We will multiply, we will see how we can multiply a matrix with a scalar quantity. Let's say, like, for example, our matrix is like 2, 4, 6, 1. Let's say this is matrix A. So to find, like, we want to multiply with a scalar like a 3. So 3A will be 3 into 2, 4, 6, 1. So we will multiply each element by the scalar. So multiply each element by the scalar quantity. So for example, 3A is A is this, is the matrix. So 3A will be 3 times 2, 3 times 4, 3 times 6, and then 3 times 1. You multiply each element by 3. So our answer will be 3 times 2, 6, 3 times 4, 12, 3 times 6, 18, 3 times 1, 3. So I want it to be that. But when we are multiplying, this is B. Let us put a B there. 1, 3, 4. So, for example, we want to multiply a matrix by a matrix. So, A times B. A times B equals A 2, 4, 6, 1 times 1, 3, 4, 5. So, in this case, we will multiply, when we are multiplying, let's see the rules of multiplication. We multiply, matrices can be multiplied by a matrix if the number of columns in the first row, each element on the top row is multiplied by corresponding elements in the first column. So, when we are multiplying, I could put rules there before I write that. But anyway, each element on the first row is multiplied by corresponding element on each column. So, what are we saying by this? You take elements of the first row, multiply by its corresponding element on the first column. Again, you come and take the first row with elements of the second column. Tuna multiply hivi. Like hivi, then ikuze hivi. Then again, hivi. So in this case, how are we doing that? These arrows. Let me put it with another different Bible. Yeah. I hope watu wanaelewa. Nenda hivyo. Okay. Teremka hivyo. So this times this times this. Tena hii tutateremka hivyo. Then again we do this too. Hii pia. But let us do the first one first. First. So, ni hivi. Tumesema elements of the first row times elements of corresponding elements of each column. So in this case, we'll start by 2. So it is 2 times 1 plus 4 times 4. 4 times 4. 2 times 1, 4 times 4. Sawa? Tunaenda hivi. 2 times 1, 4 times 4. Then, tunaendelea tena. The first row again with the first column. Tuna multiply row na column. So again we say 2 times 3 plus 4 times 5. 4 times 5. Sawa. Yeah, tuna multiply the first row with each column. Corresponding element with each column. 2 times 1 plus 4 times 4. 2 plus 3 times 4 times 5. Plus 4 times 5. Sawa. Then we go to the second row. We go to the second row. 6 times 1 plus 4, 1 times 4. 6 times 1 plus 1 times 4. Sijui kama tunapatana hapo. Then we go again 6 times 3 plus 1 times 5. Mpaka hapa I hope tuko sawa. So AB itakuwaje? AB itakuwa 2 plus 16, then itakuwa 6 plus 20, then hapo itakuwa 6 plus 4, then hapo itakuwa 18 plus 5. Kiasi. So itakuwa 16, 17, 18, 18, 20, 26, 4 plus 10, 18 plus 5, 18, 19, 20, 21, 22, 23. Sawa sawa. So that's how you multiply. We multiply rows with corresponding elements on the column. So, mpaka hapo I hope somebody is getting something. Can we do another example? Let us do another example like atufuti vitu mingi. Let us do the second example. Tafuta tu hapa. Tufute hapo. Alafu to change easy. So meaning to change. So let us do this example like. So let us do this example. Matrix A we can change like inakuwa 3, 5, 4, 2. Then hapa itakuwa 1, 2, 7, 4. So A times B, we want to multiply A times B. A, B. So A, B, each element on the first row is multiplied by corresponding elements of each column. So AB takuaje equal 3, 5, 4, 2 times 1, 2, 7, 4. So kwa pio by rangi nasema the first row na multiply each column ikiendelea. So 3. So tutaanza by saying 3 times 1 plus 5 times 7. Sindio? 3 tunaenda kwa the second column. 3 times 2 3 times 2 plus 5 times 4. Then we say 4 times the second row. Second row, each column. 4 times 1 plus 4 times 7. Then 4 times 2, the second column. 4 times 2 plus 2 times 4. So takuja ikue 3 plus 35, 6 plus 20, 4 plus 28, then 8 plus 8. So our answer of A B is equals to 35 plus 3. 35, 36, 37, 38. 20 plus 6, it's 20. Yeah. 20 plus 6 is 26. Then 4 plus 28, 32. 8 plus 8 is 16. So A, B is that. I hope up to that point tumeelewana. Multiplying, addition, multiplication and subtraction of a 2 by 2 matrix. Hope tuko sawa. So multiply the first row with each column, the second row with each column. Okay? Sawa. So after we have done that, we can do transpose of matrix. Transpose of matrix. So this is just to interchange elements of rows and elements of columns. To interchange, exchange rows, the elements on rows become column. Yeah? Interchanging rows and column. Interchanging rows and column. So please, if you're watching this lecture up to this point, make sure you subscribe. Subscribe, like, share, alafu comment. At least we'll be motivated. Sindio? I hope unaelewa. Sindio? And you see, when I had a teacher ambaye alikuwa anasema ukiwa hapa mbele you will not see any mistake, wewe utaendelea tu. So mwenye anakusikiza ndio ataona mistake. So if you are seeing any mistake pia you can comment down below turekebishe mistakes zenyewe, sivyo? So transpose of a matrix, we mean interchanging rows and columns. So the first row becomes the first column. The first row becomes the first column. Hivyo, the second row becomes the second column. Hivyo na kuendelea, sawa? So in this case we were saying that we are doing a 2 by 2 matrix. For example, this 2, 4, 6, 8. This is matrix A. Tunaita matrix A. So tunaita kwa jina. Mbona nione kama inaendelea kunirecord ama nasema tu story za jaba. Okay. So, nasema the first row becomes the first column. The first row becomes the first column. So, in this case, first row ni hii. Hii ndio first row. Inakuwa column. And hii first row inakuwa the first column. So, the first row 2 na 4. Then, the second row becomes the second column. So, 6 and 8. Simple. So, this is transpose of A. T. Yeah? Transpose of A. Ama tunaiandika in short form. Watakwambia A na waeka kati kadogo juu. So that means transpose of A. Transpose of A. is, it's denoted as A na kati juu. A na kati juu. I think that is very simple. So for example, let us do a small example. Hii bado tujaingia kwa matrices. Hey, noma juu. Noma. Bado tujaingia kwa matrix. So for example, matrix C is equals to 4, 1, 10, 9. Sindio? That is matrix C. Find CT, transpose of C. So the first row becomes the first column. So the first row for 1 becomes the first row inakuwa the first column. Second row becomes the second column. So C transpose is that. That is very simple. Tuendelee ama tuachie hapo? So I want us to do a small exercise ambayo ina involve vitu zote zenye tumefanya. Ina involve vitu zote ambayo tumefanya. Addition, subtraction, and transpose of matrix. So let us do a big example. Let us do a very big example like. So this is transpose A is 2619 13. B is 44864. So that is transpose A and B. So first find A, find AB. Then 2, find A minus. Let us find A minus B. Then find AB transpose. See? Yeah. We can also find the transpose of this. So ya kwanza, find A minus B. So what do? You quote A minus B is equals to A ni 2613, B ni minus B ni 4864. So kiendelea is equals to niendelea hapa chini. So is equals to A minus B is equals to 2 minus 4. So tusema corresponding elements. 2 minus 4. Tuandike vizuri. Is equals to 2 minus 4. 2 minus 4. 6 minus 8. 6 minus 8. 1 minus 6. And 3 minus 4. Corresponding elements. So A minus B is equals to 2 minus 4 is negative 2. 6 minus 8 is negative 2 also. 1 minus 6 is negative 5. 3 minus 4 is negative 1. So A, B is that. So find the transpose of A minus B. So A minus B T is equals to, the first row becomes the first column. So the first row becomes the first column. So minus 2, minus 2. The second row becomes the second. column minus 5 minus 1. So that is A minus B transpose. The first row becomes the first column, the second row becomes the second column. Hello. Then find A, B. So this one is A 2, 6, 1, 3 times 4, 8, 6, 4. So itakuwa 2, the first row times each column. So 2 times 4 plus 2 times 4 plus 6 times 6. 6 times 6. 2 times 8 plus 2 times 8 plus 6 times 4 plus 6 times 4. And the second row with each column. 1 times 4. 1 times 4 plus 3 times 6. And then again with the next column is 1 times 8 plus 1 times 8 plus 3 times 4. If you can notice when you are arranging that, unapata hapa inafanana. Unaona? So if you have gone wrong, utajua hapo isipofanana. Sawa? Utajua hapo isipofanana, utajua there is somewhere you have gone wrong. So make sure you do right. Then as you go on, unaendelea kuconfirm vitu unafanya, si ndio? So 2 times 4 is 8. 8 plus 6 times 6, 36. Then hapo ni 16 plus 24. Na ni numbers kubwa. 4 plus 3, 18. Then hapo inakuwa 1 times 8 plus 3 times 12, si ndio? Then is equals to 36 plus 8. Inakuwa 40 ngapi? 8, 9, 10, 11, 30. 43. 44. Oh yeah, 44. Kumbe mstudent yangu anasikia. 16 plus 24. 16 plus 24, 40. Yeah. 4 plus 18.
4 plus
18. 22. Then 8 plus 12 is 20. So that is A, B. But they have said the transpose of A, B transpose. So it's equals to the first row becomes the first column, the second row becomes the second column. So in this case, the first row becomes the first column, so 44, then 40. The first row becomes the first column, the second row becomes the second column, 22, 20. Simple. Simple. Okay. So we want to go to something else. We want to go to something else, like finding the determinant. Finding the determinant. We want to find the determinant of a 2 by 2 matrix. Before we go to a 3 by 2 matrix, see, hapa I hope tumeelewa. finding the determinant of a 2 by 2 matrix, or in other case we can say that we are finding the determinant of a matrix of order 2 by 2. Yeah? Tukisema 2 by 2 matrix, we can also say of order 2 by 2. So how do we find the determinant? So determinant is found by subtracting the so we will have to know the leading diagonal and the other diagonal. So we subtract the subtract the multiplication of the elements of the leading diagonal from subtract the multiplication of the elements of the leading diagonal minus the multiplication of the other diagonal. Tusikwe na stress. So if this is matrix A, we identify the leading diagonals from this one. If the first column where the diagonal line is the leading diagonal. So ujue hiyo. Uangalie the first element, the element of the first row, first column. Hiyo element ya kwanza. Then when you go diagonally, not perpendicularly ni hivi, diagonally ni hivi. Sawa? Hivi. So ukienda hivyo inakuwa the leading diagonal. Then this other diagonal is the other diagonal. So when you multiply the elements of the leading diagonal. So in that case it will be 2 times 5 minus the multiplication of the other diagonal, which is 6 times 1. What you find is the determinant. Inaandikwa hivyo with straight line. So is the 2 times 5 is 10 minus 6 times 1 is 6, ndio. So our determinant is 4. Okay? So when you find a matrix that has a straight line is its determinant. So for example, we have matrix C as 5, 2, 3, 9. Okay? If that is matrix C, they will tell you find its determinant. In a curve straight. Ushaiona matrix in a curve straight? I've never written a matrix that has straight line. So if it has straight line, it's its determinant. Okay? So then you'll say the elements of the leading diagonal is that. So it is so C straight line is 5 times 9 minus 3 times 2, which is equals to 5 times 9 ni ngapi? 45 minus 3 times 2 is 6. So it's 39. minus 6. Yeah, 39 is your determinant. Very, very simple. So, having found the determinant, we want to see how you'll find inverse of a matrix. Inverse of a matrix, of a 2 by 2 matrix. Let us look at that. Inverse of a 2 by 2 matrix. So the determinant tunajua, si ndio? Up to that point, I hope I am talking to somebody. Please subscribe. Okay, so what to see? Inverse of a matrix. So inverse of a matrix is like finding the reciprocal of a matrix. So we want to do inverse of a 2 by 2 matrix. So we'll start by a 2 by 2 matrix, and then we go to a 3 by 3 matrix. And we said, when I say a 2 by 2 matrix is a matrix of order 2 by 2. It has 2 rows and 2 columns. That is just a revision. So we have the procedure. So the first thing you'll have to do when you are doing an inverse of a matrix, or you will find the determinant. So this is the first step you do. You'll find the determinant. Then, after you found the determinant, you will interchange elements in the leading diagonal. You know where the leading diagonal is. So, interchange elements then number 3, you'll multiply elements in the other diagonal by -1. So lastly, you will multiply the resultant matrix by the reciprocal of the determinant. The reciprocal of the determinant. Determinant in define. So let us start with the first step. So for example, we have a matrix. We have a matrix 5. So this is matrix A, which is 5, 3, 4, 2. So those are elements on a matrix A. So find A inverse, or find the inverse of A. It's denoted as A raised to -1. Or I can just say find the inverse of matrix A. So you can find either it can either be written as this or just in long form yake ni just find the inverse of matrix A. So the first step, find the determinant. We know how to find the determinant. Okay, it is 5, 3, 4, 2. The determinant. I say determinant can be written as det. Det or that. So find the determinant of that. So we say that we identified the leading diagonals. The leading diagonal. You first identify the leading diagonal, which is, we said you start from the first column, the element of the first column, first row, going diagonal wise, not perpendicular. Perpendicular is at yani chini yake 90, but perpendicular, yeah, but diagonal yake twende hivyo. So 5 and 2, that is the leading diagonal. So that is the leading diagonal. Then the other diagonal is just the other diagonal. So we said we multiply elements on the leading diagonal, 5 times 2, minus element on the other diagonal, which is 4 times 3. So it is 10 minus 12, which is equals to -2. So the determinant is -2. So we go to the next step. Tuiache tu hiyo, tutaitumia. So we go to the next step as interchange elements in the leading diagonals. Tumeona penye leading diagonal iko. So just interchanging the element. Tulisema each number here is called an element. So interchange elements in the leading diagonal, meaning the 2 will come here, the 5 will come here. Just interchange. Okay? So our resultant matrix, 2 itakuja hapo juu, 3 ikuje hapo, na hiyo 5 ikuje hapo. So we have done the second step. So this is the step 1. Step 1, we found the determinant. Step 2, interchange elements in the leading diagonal. Interchange elements in the leading diagonal. That is step 2. Step 3. Step 3 is to do what? Multiply elements in the other diagonal by -1. So elements of the other diagonal we multiply by -1. So the step 3, 2, then 3 times -1, then 4 times -1, then 5. Sindio? So our resultant matrix will be 2, -3, -4, 5. Sindio? So the last step, which is step 4, step 4, niangaliwa kama wataona hapa kiandika. So step 4, it is, we do what? Multiplying the resultant matrix by the reciprocal of the determinant. The reciprocal of -2 is, the reciprocal of -2 is -1/2, sindio? So it will be 2 -3 minus 4, 5. Okay. So we multiply by -1/2. Sindio? So it will be 2 times -1/2, -3 times -1/2, -4 times -1/2, and 5 times -1/2. So it will be 2 times -1/2 will be 2 times -1/2. So it is -1, -1, -3. So here tutakumbuka ile kitu yetu ya
hapa itakuwa 3
tutakumbuka ile kitu ya positive, negative plus negative times a negative is equals to a positive. A positive times a negative is equals, so negative plus a negative times a negative plus A positive times a positive is a positive, negative times a positive is equals to a negative, and a positive times a negative is negative. So to put in mind that one. So when we say negative 3 times negative a half, itakuwa 3 over 2. Sindio? 3 over 2. Then negative 4 times negative 4 times negative a half, hapa 1, hapa 2, sindio? So itakuwa positive 2, sindio? Then 5 times negative a half will be minus 5 over 2. So this is the A inverse. This is the inverse of
hata hapo kama ni fraction naona. Okay, it's okay, but ile negative 1 ingeza kuwa tu
1 over
2.
Wapi hapa?
Okay, it's okay.
So it is, yeah. So that is A inverse. A inverse. If this is A inverse is that. Okay? Yeah. So we have known how to do inverse of 2 by 2 matrix. So we follow the steps. Step 1, we find the determinant. We have found the determinant, the leading diagonal, multiply elements, the leading diagonal minus element on the other diagonal. We find our determinant as negative 2. Then step 2, interchange elements in the leading diagonal. So the leading diagonal is this, sindio? The leading diagonal is that. So we interchange elements. So the 2 inakuja hapa juu, 5 inakuja chini. Then the third step is multiply elements in the other diagonal by negative 1. So we have identified the leading diagonal, the other diagonal is this. So it will be 2, then 3 times negative 1, and 4 times negative 5. Inatupea hiyo. Then we go to the last step, which is step 4. We multiply the resultant matrix by the reciprocal of the determinant. We found our determinant as negative 2. So its reciprocal, it will be negative a half. So the resultant matrix, we multiply by negative a half. And we learned about multiplying a matrix by scalar quantity. So we say that if a matrix, if you want to multiply a matrix by a scalar quantity, you will multiply each element in the matrix by the scalar quantity. Sindio? So we multiply each element by negative a half. So tutapata our matrix, which is A raised to negative 1, as that. So we have found that there is something small that I want us to do. We have A and we have A inverse. We want to see if we multiply A, matrix A, by matrix A inverse, what do we get? So that is something I want us to do. Okay, before we do that, okay, let us do this. Let us put a note first. Before we continue, let us put a note. An NB. 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 If a matrix has, if we find that for a particular matrix, we find that its determinant is 0, that element has no inverse. Tuseme we find that a matrix, when you are finding the determinant, unapata ni 0. Tunasema hiyo element haina inverse. Let me just, if the determinant is if the determinant of a matrix is 0, find the leading diagonal the elements of the leading diagonal minus elements of the other diagonal, umepata 0, then the matrix has no inverse. The matrix has no inverse. Haina inverse, because for example here is 0. When you multiply by the reciprocal of the determinant, the fourth step, which is multiply the resultant matrix times the reciprocal of the determinant, unapata ati hapa hivi you multiply by, if the determinant is 0, uta multiply hapa by 1/0, of which ukimultiply hapa na 0, si itakuwa tu 0. So meaning it has no inverse. It has no inverse. We refer to them as singular matrix. We refer as singular matrix. We refer to them as singular matrix kwa sababu haina inverse. When you do its inverse, say for example, let's say just A, B, C, D times the inverse of the determinant. Determinant is 0. Si kila kitu hapa itakuja ikue 0, 0, 0, 0. Yeah? That is a singular matrix. Its determinant is its determinant is 0. Its determinant is 0. If the determinant of a matrix is 0, if the determinant of a matrix is 0, the matrix has no inverse. We refer to them as singular matrix. Okay. So tutakuja hapo tufanye example moja kali. I'll come to that. There is something I want us to do with multiplying A times A inverse. This was just an NB, andika kando NB, that if the determinant of a matrix is 0, the matrix has no inverse. We refer to them as singular matrix. So if somebody asks you what a singular matrix is, you uko na jibu, si ndio? Its determinant is 0. A singular matrix is determinant is 0. Si sawa hiyo, because tutakuja nayo tutumie mahali. Okay? Yeah. So tumesoma about getting the inverse na tumesoma about singular matrix. Determinant is 0. Okay? So tunafuta hapa. What has to multiply? Nataka to multiply. We want to multiply, find A times A inverse. Multiply matrix A times its inverse. Okay? So utakuwa matrix A is 5, 3, 4, 2 times -1, 2, 3 over 2, then negative 5 over 2. So when you are multiplying, tulisema you multiply row each column. Row each column, row each column. So we start as so A inverse is equals to natumia space kubwa, handwriting yangu ni kubwa sana. So anyway, yeah. So it's 5 times negative 1 plus 3 times 2, then 5 times then 3 times 2, then again 5 times 3 over 2 plus 3 times negative 5 over 2. Then we go to the second row with each column, so 4 times negative 1 plus 2 times 2, then 4 times 3 over 2 plus 2 times negative 5 over 2. So if you notice, let us see if we're correct. And inafanana. So we continue. That is just something that you can just notice, yani ukipitia una notice tu hapo kuna resemblance fulani na unapiga tick, alafu unafanya nini? Unaendelea, unalala. Student wangu amelala. Surely. Na mimi napiga domo hapa. I hope wewe mwenye uko una watch haulali kwa sasa. Ni story gani? Anyway, tuendelee na wenye tunaendelea na wao. That's why you need a calculator. Tukikuwa tunafanya hesabu unafanya calculator. Unafanya calculation anyway. Ni sawa. So 5 times 5 times negative 1 is negative 5 plus 3 times 2 3 times 2 ni ngapi? 6, ndio? 5 times 3 over 2. 5 times 3 over 2 inakuwa 15 divide over 2 plus 3 times negative 5 over 2. Negative 15 over 2. 4 times negative 1. 4 times negative 1 is negative 4, sindio? 4 times negative 1 is negative 4 plus 2 times 2, 4, then nimekaribia, negative 4 plus 4, then 4 times 3 is 12. 4 times 3 ni ngapi? 12, yeah. 12 over 2 plus 2 times 5 negative 2 negative 2 times negative 5 times 2 times negative 5 ni ngapi? 10. Negative 10 over 2, si ndio? So itakuja ikue a negative 1 is equals to negative 5 plus 6 itakuwa 1, si ndio? 15 over 2 plus minus 50 over 2 itakuwa 0, si ndio? Tulikuwa tumeandika hapa, by the way, positive times a negative is equals to a negative, si ndio? Minus 4 plus 4, 0. Tunakumbuka hiyo? Hapa ni 0, huku ni negative, si ndio? Negative 1, negative 2, negative 3, negative 4. So kwa negative 4 plus 4, 1, 2, 3, 4 inakuja kwa 0. Hizi very important. So I hope unazikumbuka pia. So 12 plus minus 10. So it's 2 over 2. 2, sitakuwa 2 over 2, which is 1. Okay. So you get 1. So this type of matrix, yeah, inaitwaje? So if you multiply a matrix times its inverse, inafaa ikupe a unit matrix. Unit matrix. So this is a unit so NB A times A inverse is equals to a unit matrix. Okay? Sikutaka kuandika in long form that when you multiply a matrix times its inverse, itakupea unit matrix. It's just the same as this. NB, a matrix times its inverse, it gives you a unit matrix. But sijui niandike kwa wale NB, nione kama inafika hapo. Iko sawa. NB, if you multiply a matrix by its inverse, you get a unit matrix. You get a unit matrix denoted as I. Denoted as I. A unit matrix ni the diagonals, the leading diagonal is 1. So the elements in the leading diagonal is 1 and the other element is 0. Yeah? So when you multiply a matrix times its inverse, it will give you a unit matrix I. Okay? Yes. So that's just about inverse of a 2 by 2 matrix. Then after we've done that, we want to see how we solve simultaneous equation using matrix. Okay? Solving simultaneous equation using matrix. Yes? Mpaka hapo tuko pamoja. Okay.